Hello everyone, today I will be introducing infrared radiation and its basic concepts. Infrared radiation is a type of electromagnetic radiation that is invisible to the human eye. Although we cannot see it, we can feel it as heat. In fact, all objects with a temperature above absolute zero emit infrared radiation. Infrared waves are electromagnetic waves that carry thermal energy. They have wavelength ranging from approximately 7 nanometers to 1 millimeter and frequency between 300 GHz and 430 terahertz. Infrared waves have longer wavelength than visible light but shorter wavelength than microwave. Infrared radiation is a part of the electromagnetic spectrum. It is located between visible light and microwave. The electromagnetic spectrum consists of radio wave, microwave, infrared radiation, visible light, ultraviolet rays, X-rays, and gamma rays. Like other electromagnetic waves, infrared waves travel at the speed of light and do not require a medium to travel. The importance of infrared technology in real life is enable non-contact temperature measurement, helps detect heat in dark environments, improves safety and security monitoring, supports medical diagnosis and health security, increases efficiency in industrial procession, used in many everyday technology. There are many applications of infrared technology in our daily life. For example, TV remote control, infrared thermometers, thermal imaging camera, and motion sensor.
Now, I will explain how infrared radiation works. Infrared radiation is a type of electromagnetic wave with wavelength ranging from 700 nanometers to 1 millimeters. It is invisible to the human eye but can be detected as heat. All objects above absolute zero emit infrared radiation. Thermal sensor can detect this radiation and convert it into temperature readings or thermal image. Some key characteristics of infrared radiation are that it transfers heat energy, travels at the speed of light, and cannot be seen by humans. Infrared radiation has many practical applications, including thermal cameras, remote control, medical imaging, and security systems. This technology uses infrared waves to detect heat, transmit signal, and monitor objects or people. Next, I will explain the blackbody radiation concept. A blackbody is an ideal object that absorbs all incoming radiation and emits radiation based on only its temperature. In reality, every object behaves somewhat like a blackbody. All objects continuously emit infrared radiation because they have thermal energy. The amount of radiation emitted depends on their temperature. As an object temperature increases, it emits more infrared radiation or energy, and the intensity of the radiation becomes greater. This is why hotter objects appear brighter in thermal image. Infrared radiation is a form of thermal radiation, and most everyday objects emit energy mainly in the infrared region of the electromagnetic spectrum. Understanding the blackbody radiation concept helps us explain how heat is emitted and detected in applications such as thermal cameras and temperature sensing technology. Next, I will explain infrared sensor and infrared cameras. Infrared sensor detect heat, radiation, and convert it into electrical signal. They are commonly used in motion sensor, automatic doors, and security system. Infrared camera capture heat emitted by object and convert it into thermal image. Different colors represent different temperature. These cameras are widely used for electrical inspection, building inspection, and medical diagnosis. Overall, both technologies help us detect and monitor heat efficiently. Now, let's look at thermography and its application. Thermography is a technique that uses infrared camera to measure temperature without direct contact. It produces thermal image where different colors represent different temperature. It can also identify hotspot and abnormal heat patterns, helping detect problems before equipment fails. Thermography is widely used in medicine, building inspection, electrical system, and firefighting. Overall, it is a safe, fast, and effective method for temperature monitoring and fault detection.
Applications and real-world implementation. First, in medical application, Infrared thermometers can check the temperature of a person without coming into contact with them, something which came to the fore during the COVID-19 pandemic. Next, in military application, night vision goggles can be used to spot combatants in low or zero light conditions. Lastly, homeland security. Infrared sensors have the capacity to generate image continuously around the clock and in real time to effectively detect and track instructions. These sensors are undetectable and can see a person several kilometers away during the day or at night and in all weather.
My name is Zulaika binti Fauzi, and now I'm going to walk you through the real world slide of infrared radiation technology. We will look at its major benefits, the engineering challenging that we face, and how we keep it safe, private, and well maintained. Let's start with the 4 big reasons why we use this technology. First is non-contact. We can read temperature from safe distance without touching anything. Second is fast monitoring. It gives us instant real-time thermal maps. Third is darkness utility. It does not need light. It sees heat, mean it works perfectly in absolute darkness. And fourth is energy efficiency. It uses very little power, make it perfect for long-term use. Of course, no technology is perfect. These are 3 main hurdles. First, it is expensive. Infrared light cannot pass through normal glass, so we have to use rare material, germanium, for the lens, which costs more. Second, weather effect. Heavy rain, fog, humidity can block the signal and lower accuracy. Last is we cannot see through walls or glass. Only measure in surface temperature, not what is hidden inside. So this is the table that I already created. Basically, there is strategic benefits and operational challenge. To make decision easier, this table is already balanced with pros and the cons. So I can conclude that for range, we can see from far away, but solid object can block us. For reliability, we can see in dark, but weather can hurt the accuracy. For maintenance, there is no physical wear and tear, but the sensor can drift over time. And for the cost, it is cheap to run, but it is expensive to buy first. So because this camera can track people in total darkness, privacy is a major priority. To protect people, we recommend data abstraction. This means that we only record heat, shape, and temperature, never high definition video or face. We also make sure to put up a clear sign where thermal monitoring is active to stay legally compliant. So lastly, to keep the system accurate, we need a simple maintenance plan. So first, we use the automatic shutter calibration, which is NUC. What it does is that the camera occasionally resets itself to clean up a visual noises caused by internal temperature changes. Second, we need to protect the germanium lens with maybe a scratch-resistant coating and also clean with a specialized residue-free solvents.
I will be presenting the future development of infrared technology and its importance to the society. Infrared technology continues to evolve with the advancement of modern science and technology. One major development is the integration of artificial intelligence or AI with thermal imaging system. AI can analyze thermal image quickly and accurately, helping doctors diagnose diseases, security personnel monitor suspicious activities, and engineer detect equipment problem before they become serious. Another important investment is the development of smart infrared sensors. The sensors are becoming smaller, more sensitive, and more energy efficient. They can be integrated into smartphone, wearable device, smart homes, and industrial system to provide real-time monitoring and automatic process. In the medical field, infrared technology is expected to play a greater role in advanced diagnostics. Thermal imaging allows doctors to detect abnormalities such as inflammation, poor blood circulation, and certain diseases without direct contact with the patient. This makes diagnosis safer, faster, and more comfortable. Infrared technology is also become increasingly important in military and space application. Advanced infrared system improve night vision capabilities, detect hidden objects, and help satellites monitor weather patterns, environmental change, and planetary condition. In addition, infrared sensors are widely used in smart home automation. They can detect movement, control lighting system, and improve home security, and also help reduce energy consumption. To summarize that, infrared technology is an important scientific instrumentation technology that enables heat detection and monitoring without direct contact. It has transformed many fields, including healthcare, security, industry, and environmental monitoring. With future advancement in AI, smart sensor, and automation, infrared technology will continue to improve our life and contribute to a smarter, safer, and more efficient society. Now, let's look at the future impact of infrared. In conclusion, infrared radiation is a form of electromagnetic radiation that
What is infrared light? Light is an electromagnetic wave characterized primarily by its wavelength. The light spectrum is divided into segments or spectral bands. Visible light, also called white light, ranges from 0.4 to 0.8 micrometers. White light is mainly emitted by the sun. It can be reflected, absorbed, or transmitted by a body. When white light hits an object, some wavelengths are absorbed and others are reflected. The wavelengths that are reflected determine the color of the object as we see it. Light whose wavelengths are between 0.8 and 50 micrometers is infrared light, which is invisible to the naked eye. Only some animals, such as snakes, can see infrared radiation, which is proportional to the temperature of the body being observed. Any body with a temperature higher than absolute zero, 0 kelvins or minus 273 degrees Celsius, emits thermal radiation by day and night. The higher the body's temperature, the closer this radiation will be to the white light segment. For example, when a blacksmith heats a piece of iron until it's white hot, we see it as white because it is emitting radiation at all wavelengths in the visible spectrum. This relationship between radiation and temperature is described by Planck's law, which is used to calculate the intensity of thermal radiation, or radiance. This law applies to black bodies, theoretical bodies that absorb all wavelengths and emit a flux depending on their temperature for a given spectral band. Radiance can then be used to determine how effectively a body emits radiation for a given temperature. This is called emissivity. Ranging from 0 to 1, emissivity compares the radiance of the body with the radiance of a black body. The closer the emissivity of the body is to 1, the closer its radiance is to that of a black body. If its emissivity is 0.5, it emits half the radiation of a black body. A body's emissivity depends on its physical properties. For example, skin has an emissivity of 0.98, whereas polished metal bodies, like aluminum, have emissivity values that may be less than 0.1. These are infrared mirrors. If the emissivity value of a body is known, the emissivity can be used to calibrate infrared devices. The body's thermal radiation can then be captured to determine the body's temperature. Known for enabling us to see by night, infrared light is now used in many fields such as industry, defense, and remote fever detection.